Okay, so let's take a look at these questions. So the first question we were asked, what would happen if we had the graph of f of x equals x squared, and we dragged its so that its vertex was, we moved 4 units to the right and 6 units down, so that we were down here at 4, negative 6. Well, its new vertex then would just be at 4, negative 6. Its equation in vertex form would be x minus 4 squared minus 6. Again, it is, with the y value, it's exactly what we get there with the negative and the negative. But for the x value, it's the opposite of what we see in here. It's basically that what we want this to evaluate to 0 when we plug in the x value of the vertex. So we would have to plug in 4 to make this 0. So it's x minus 4. All right, to figure it out in standard form, we just do our multiplication, and then we still have to do the subtracting 6. So we get x squared minus 4x minus 4x plus 16. We get x squared minus 8x plus 16 minus 6. So we get x squared minus 8x and then plus 10. Now, if you're used to it, you would just look at the x minus 4 squared and say, we know we're going to get an x squared. We know we're going to get a double the 4 times x, so we get negative 8x, and then plus the square of the 4. So you don't have to do out the box if it's not necessary for you. What will be the equation of the axis of symmetry? X is equal to 4. And again, that axis of symmetry is just, if this is our new parabola here, our axis of symmetry is just this vertical line that passes through here and is the line, it's sort of the mirror for the parabola. Everything on the left side of the axis has a reflection on the right side of the axis. So if we want to know what are the coordinates of the y-intercept, well, the easiest way to get those is from standard form. So the y-intercept is always just going to be equal to that number here, and its x value will always be 10 since it's a point right on the y-axis, so x is always going to be 0. The point of reflection then for that is if this is if 0, 10 up here, let's say, is where this thing crosses the axis, let's say that's 0, 10 up there, then over here on the other side of our axis of symmetry is a point with the same y-coordinate, but its x-coordinate will be 8, because to get from the y-axis to the axis of symmetry, we had to go 4 units, and then another 4 units to get to this reflection point. So that gives us an x value of 8 for that. Okay. So again, we have the point 8, 10 here. Okay, where will our original x squared intersect the new parabola we created? So we want to set these equal to each other, minus 8x plus 10. We have an x squared on both sides, so when we subtract that out, all we're left with is 0 equals negative 8x plus 10. We can add 8x to both sides to get 8x is equal to 10. Then we divide both sides by 8 to get x is equal to 10 over 8 equals 5 over 4 equals 1.25. But we then need to figure out, okay, what about the y value? So we would plug our x value in. We can plug it into either equation, since this would be a point that lies on both. And so when we plug it in, we clearly are going to get the point 1.25, 1.25, or 5/4, 5/4. Okay. So here we're asked to find the coordinates of the vertex of g of x equals 2x squared minus 12x plus 17. Okay, so what we need to do here is convert this into vertex form. So we write this out. We have 2x squared minus 12x, and then what we do is we keep this separate here. And we then factor out of both of these the largest factor that we can factor out from their coefficients, which is a 2. That leaves us in here x squared minus 6x plus 17. Now, the goal here is to create this, make this inside here into a perfect square trinomial, And so what we have to add here is negative 6 over 2 squared, which is really just negative 3 squared, or 9. But if we're adding 9 inside here, then we're really adding 2 times 9, or 18, and that means that to offset that, we have to subtract 18 out here. And so now we have 2x squared minus 6x plus 9 minus 1. And the reason that we do this is because this can then be factored to 2 times x minus 3 squared minus 1. And that means that the vertex, which is what the question was asking, is 3, negative 1. Again, the opposite of this value here, and then this actual value here. Okay, now we're asked, given the parabola 3 times x squared minus 3 times x minus 1 squared minus 6, we want to find the two x-intercepts. When we already have it in vertex form, what we can do is set this equal to 0, because what we're looking for are the two x values where this thing crosses the x-axis. That means that y would be 0, which means that we can say this thing has to equal 0 in order to get the correct x value. All right, so then we just start to work our way. We would first add 6 to both sides. We would then divide both sides by 3. And the advantage of having an equation is that we can just divide out the 3 from both sides. And since we have an equation, we don't have to worry about offsetting that. Now we can take the square root of both sides, x minus 1, and here we have to be careful. This is equal to either the positive or negative square root of 2. Then from there we get x is equal to 1 plus the square root of 2, 1 minus the square root of 2, and it'll turn out this is a value of about 2.4, approximately equal to negative 1.4. Okay, find the remaining 3 points, the y-intercept, reflection of y-intercept, and vertex. Okay, the vertex is certainly easy to get, and that's just going to be the v is equal to 1, negative 6. The y-intercept, we can just plug in 0, and we would get 3 times 0 minus 1 squared minus 6 would be 3 times 1 minus 6 is equal to negative 3. So the y-intercept would be at the point 0, negative 3. And the reflection, so we know that the axis of symmetry would be the vertical line that goes through the vertex at x equals 1. And so on the other side of that, from the y-intercept, would be the point 2, negative 3, which would be the reflection of our y-intercept. Okay, so then to plot this out, we would have, let's say, negative 1, negative 6 here. We'd have 0, 3 here. We would have, I'm sorry, this is a positive 1, excuse me. We would have the point 2, negative 6 over 2, sorry, 2, negative 3 over here. And then our x-intercepts, we would have the point 2.40, and then negative 1.40 up here. And so that gives us sort of a rough sketch of this. And again, our axis of symmetry goes right through this point here. And our reflection of the axis of the y-intercept is just on the other side of the axis of symmetry. Okay. All right, the point 5, 10 lies on the graph of parabola fx. If the vertex is at 10, 5, what point do we know has to also lie on the graph? Well, if we have the point, let's say 10, 5 here at the vertex, we know the thing is, we know that we also have the point 5, 10, which would be right about here. So we know this thing opens up like this. And what this also means is that on the other side of the axis of symmetry, at the point, so we go over 5 to get to x equals 10, another 5 to get to x equals 15, and we get to the point 15, 10. Again, the y-coordinates of these 2 points are the same. Okay. Okay, so now we want to find the intersection points of these two. And to do that, we're going to start by setting them equal to each other. So we have negative x squared plus 9x plus 15 equals x squared plus 3x minus 5. Just like if you're finding the intersection point of two lines, you can set them equal to each other when they're in the y equals mx plus b format. So we know that y is equal to negative x squared plus 9x plus 15. Y is equal to x squared plus 3x minus 5. We set them equal to each other. But in order to solve a quadratic, we want to get it equal to 0 and then use the vertex form. So we're going to set the left side equal to 0. So we'll say this is going to equal 0 by adding an x squared to both sides, by subtracting a 9x from both sides, and by subtracting 15 from both sides, so we end up with this. All right, so now what we're going to do is we're going to say 0 equals, and we're going to factor out x squared minus 3x minus 20. We're going to have 0 equals 2 times x squared minus 3x plus negative 3 over 2 squared. Again, half of the negative 3 squared minus 20. But since we're adding something inside here, we're going to have to add it inside over here as well. So we're going to add 2 times negative 3 halves squared. Okay, so now we're going to keep working this out. So this, on the left side, this is going to end up being equal to 2 times 9/4, so this is going to be equal to 9 over 2, or 14, or 4.5. Equals 2 times, here we're going to factor this, 3 halves squared minus 20. So we're going to add the 20 to both sides, so we're going to get, this is really 4.5. So we end up with 24.5 equals 2 times x minus 3 halves squared. Then we're going to divide both sides by 2 to get 12.25 equals x minus 3 halves squared. 12.25 plus or minus is equal to x minus 3 halves. Okay, 12.25, sorry, plus or minus square root of 12.25. This is a perfect square, so, and the square root of it is 3.5. So we have plus or minus 3.5 equals x minus, let's say 1.5. So we get that x is equal to 1.5 minus 3.5 equals negative 2, or x is equal to 3.5 plus 1.5 is equal to 7. When we plug in 7 to either one of our equations here, we're going to end up getting, so we would have 7 squared plus 3 times 7 minus 5 would give us 49 plus 21 would be equal to, sorry, this is a 5 here, not a 7. So we end up getting 5 squared plus 3 times 5 minus 5 is going to give us 25, 40, 35. So we're going to have the point 5, 35. And then when we plug in negative 2, we're going to get negative 2 squared plus 3 times negative 2 minus 5 is going to give us 4 minus 6 minus 5 is going to give us negative 7, so we're going to end up with negative 2, negative 7. Those are our 2 points of intersection. Okay. Suppose that you found yourself on Jupiter standing on a platform 100 meters above the surface and shot a projectile upwards at a velocity of 125 meters per second. Your height after t seconds is given by this equation, negative 12.5 t squared plus 125 t plus 100. How high is the ball after 7 seconds? Just plug in 7. So it'd be 7 squared here plus 125 times 7 plus 100. And this is going to give us negative 12.5 times 49 plus 125 times 7 plus 100. This is going to give us 708.48. Over here, we're going to get negative 612.5. Okay, when we add these together, we add these two together, we get 262.5 plus 100. So we get 362.5. And that's meters. That's how far it'll be above the surface. Okay, when will it reach its maximum height? What will that height be? We need to make sure that we answer both parts of this. So we're going to go to vertex form. And so what we end up with then is we start with negative 12.5. We're going to factor that out. And so that's going to leave us t squared. Over here, we're going to get minus 10t because of the two negatives. And then over here, we're going to get plus 100. So we're going to get negative 12.5 times t squared minus 10t plus half of negative 10 squared is 25. So out here, we're going to subtract negative 12.5 times 25, which means we're going to end up adding something. So we're going to get negative 12.5 times t minus 5 squared plus 100 plus 12.5 times 25, which is 312.5. So we end up with negative 12.5 times t minus 5 squared plus 412.5. So it reaches its maximum height of 412.5 meters after 5 seconds. Okay. Next one, when will the ball reach the ground? Okay, so that means we want to take our vertex form and set it equal to 0 and solve. So we would say 0 equals negative 12.5 times t minus 5 squared plus 412.5. All right, so the first thing we'll do is we'll subtract 412 from both sides to get this times t minus 5 squared. Then we divide by negative 12.5 on both sides. And when we do that, this gives us 33 over here. And over here now we just have t minus 5 squared. That means that root 33 is equal to plus or minus is equal to t minus 5. So t is equal to 5 plus or minus root 33. And we're going to rule out the negative because it won't make sense in this. So t is equal to 5 plus root 33. And that's just going to give us that t is equal to 5 plus approximately 5.74. So we get, it's going to take 10.74 seconds to hit the ground again. Okay. Okay, and for the honors version of this, we have our equation, which is negative 12.5 t squared plus vt, we don't know what v is, plus 100. And we want to get this into vertex form. And so we know that when we do, that the y value of the vertex is going to be equal to 825, which is double the 412.5. All right, so going into vertex form, we have negative 12.5 times t squared, or times t squared, minus v over 12.5. So that's the equivalent of plus v over negative 12.5. Plus, and then we're going to take, and this is times t. Then we take half of our coefficient here, which is v over 12.5, and we square it. So that's going to give us v over 25 squared. And then out here we still have our plus 100. And then we're going to end up having our plus 12.5 times v over 25 squared. Okay, this part here is the y value of the vertex, and that has to equal 825. So we have 100 equals, or I'm sorry, we have 825 is equal to 100 plus 12.5 times v squared over 625, which is 25 squared. And so we'll get 725 by subtracting 100 from both sides equals 12.5 times v squared over 625. So here we're going to divide both sides by 12.5. We're going to multiply both sides by 625, and that's going to be equal to v squared. This is going to give us 36,250 is equal to v squared, which means that v is equal to the square root of 36,250, which turns out. So it's equal to 25 times the square root of 58, or approximately equal to 190.39 seconds. So that's the value that v would have to be in order to get it up to a height of 825 feet. The other thing that you could have done is if you figured out how much it rose from its original height. So originally it went from 100 up to 412.5, and now we want to see what does it take to get from 100 to 825. So the first one would be 312.5, the second one would be 725. If you then divide 725 by 312.5, whatever value you get, you take the square root of that and you multiply it by your original velocity of 125, and you'll get